today let's start with chapter number first, number system. In this chapter, I will tell you about the types of number system. We have decimal number system and binary number system. We have different types of number system, and then I will tell you how to convert them into the different number system conversion. Now, let's start with the chapter. Have you ever considered how computer interprets keys on the keyboard? Data organized by human. From an early age, we are introduced to the concept of number and counting. Our number system is based on 10. Let's learn about the number system. From early age, you know that we depends upon the counting, the numbers and different things. In early times, we use sticks, stones and fingers to count the different things. And this concept of number system is going on from the later time. Now, I will tell you about the different number system and let's learn. Although the word data information, they are often used interchangeably, but there is an important distinction between two words. In the strict sense, if we talk about, data consists of raw number, which a computer organized to produce information. What it's organized, and what it produce information. Like you have different number, if you organize in a proper way, like I have number 2. I have number 2, number 3, plus sign and equals to. So, now I want to organize this number. So, how I will organize? 2 plus 3 is equals to 6. This is how I organize the number. This is the way we organize the number and produce the information. Now, a number system relates quantities to symbol. In digital system, we have type some letters and numbers, and the computer translates them into number, as computers can only understand number. Like you have written alphabets or a number, but computer will change it into number only, because computer is able to understand number only. It's binary number like 0 and 1. A computer can understand only positional number system, where there is only few symbol called digit, and this symbol represent different values, and it's depending on the position they occupy. It's depend upon the position, whatever position they occupy. Now the value of each digit in a number is determined using the digit, the position of the digit in the number, and the base of the number. Like we have different ways. If we talk about we have 2 base, 10 base, 8 base. Octal number system we have 8 base. So like this we have different bases that I will tell you in the later chapter. Now types of number system. We have 2 binary units, 0 and 1. Now computer stores data in coded or machine readable form. How? Your computer store data in a machine and readable form. Therefore characters have to represent in the form of electronic pulse. We have 2 pulses that are used to represent basic number, and what are that is your 0 and 1. And the absence of pulse represents 0 and the presence of pulse represent 1. If there is an absence of pulse, then it will represent with 0. If there is a presence of your pulse, then there will be 1. Like you can see here binary digit 1, 0. So here it will be absence and here it will be presence. Like here electronic charge white and here red. Then electronic state here will be on, because here is presence, and there will be off because there is a absence. Now number system is a way to represent. What is number system? It is the way how we represent our number in a computer system. Every value are getting from computer memory. They have defined our number system. Whatever we are giving to or getting from the computer, what it is called? It is called the number system. Now many different number system exist. A digital computer represent all kinds of data information like audio, we have graphics, video, we have text and numbers in a binary form. So the total number of digits used in number system, what it is called? Base or radix. Whatever total number of digits you are using in a computer system, that is known as base or radix. Like we have 4 different number system. What are these? We have decimal number system, and the base of decimal number system is 10, and it is from 0 to 9. Binary number system, our base is 2 and we have 2 digits 0 and 1. Octal, I have told you, octal we have base 8 and number is 0 to 7. Hexadecimal. Hexadecimal we have 16 base, 0 to 9 we have numbers and A to F we will have an alphabet. First of all, now I will tell about all the number system broadly. First I will tell you about the decimal number system. In decimal number system, I use only 0 to 9, my base is 10. What is the base of decimal number system? That is your 10 and we use 0 to 9 numbers. The decimal number system use 10 digit. How many digit they use? 10 digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and its base is 10. We have to take the base 10 over here. Then it is a system that we generally use to represent numbers. It is that type of system in which we represent number in the real life. So if any number is represented without a base, it means that its base is 10. If there is any number which do not have any base, you must know that its base will be always 10. Like 73210, 3210, 4275719. They are some example of numbers in the decimal number system. Then we have binary. In this base will be 2 and we will use 2 numbers, that is 0 and 1. So binary number system uses only 2 digits 0 and 1. This system has base 2. Digits 0 and 1 are called bits and 8 bits together form byte. 0 and 1 they are called bits and 8 bits together form byte. And half a byte, if is the half a byte is called nibble, then a nibble is the collection of bits on 4 bound. The data of a computer is stored in 2 form, that is bits and bytes. And the binary number system, it does not deal with other numbers such as 2, 3, 4, 5. For example, like we have 1 0 1 0 1 2 1 1 1 0 1 2, then 1 0 1 0 1 0 1 2. So what are these? These are the example of binary number system. Next comes our octal number system. In this base will be 8 and we will use 0 to 7 numbers. So in this base is 8 and the advantage is that it has fewer digits when compared to several. Very less digits are there to compare with the several system, and digits like 8 and 9, they are not included in octal number system. Just as in binary, the octal number system is used. Where it is used? It is used in mini computer, but with digits 0 and 7 only. Like we had 357, 237, 141, 141. What are these? These are the example of some octal number system. Now hexadecimal, we have digit bases 16 and we have 0 to 9 numbers and A to F alphabets. Right? So it means that 0, 10, 15 of the decimal number system represent respectively. This system is used in a computer to reduce large size strings. When you have to reduce large size strings, you use the binary system like 7B316, 6F16 and 4B2A16. These are the example of numbers in a hexadecimal number system. Right? Okay. Now, let's study the number system conversion. How we will convert the different number system. Now, first we will convert decimal to binary. So, in this, here, if it is written 0, 0, 0, then you have to write 0. In decimal, there is a 1, then you have to write 0, 0, 1, 0, 1. If 2, 0, 0, 10, 3, 0, 0, 11, then 4, 0, 100, 5, 0, 1, 0, 1, 6, 0, 1, 1, 0, 7, 0, 1, 1, 8, 1, 0, 0, 9, 1, 0, 0, 1, 10, 1, 0, 1, 0, and 100, that is 1, 1, 0, 0, 1, 0, 0. In this, what you have to do, divide the decimal by 2. Whatever decimal is there, you have to divide it by 2. Now keep the integer quotient for the coming iteration and keep the remainder for the binary digit. Repeat the steps and you will get 0. Till you will not get 0, you have to repeat the steps with the quotient. Right? Now, like this, we have here a division of this is given 2 divided 1, 1, 2 divided by 2. So 2 5s are 10, 2 6 are 12. So here remainder will be 0. Now 56, 2 2s are 4, 2 8s are 16. Remainder 0. 2 1s are 2, 2 4s are 8, 0. 2 7s are 14, 0. But here now you see 7 divided by 2, 2 3s are 6. Then remainder will be 1. Here 2 1s are 2, remainder will be 1. 2 1s are 2 zeros are 0. Remainder will be 1. So your binary number will be 0, 0. This. Right? Now here some fact files are given. Computer memory is measured in terms of many bits it can store. Like in 1 byte we have 8 bits. 1 KB kilobyte is equals to 1024 bytes. Then 1 megabyte is equals to 104 KB. 1 gigabyte 1024 MB. Then 1 tetrabyte it will be 1024 GB. And then 1 petabyte 1024 TB. Then we have 1 exabyte that is 1024 PB, that is petabyte. Then we have 1 zettabyte is equals to 1024 exabyte. Then 1 yottabyte that is 1024 your zettabyte. Now we have convert binary to decimal. Now the another method, first of all we have done decimal to binary, now binary to decimal. So in this binary to decimal conversion, it is done to help to read large binary numbers easily. When you have to read large binary numbers easily, then what you will use? You will use your binary to decimal conversion. There are two methods to convert a number from binary to decimal, that is positional notation method and doubling method. We have two methods. First is positional notation method and doubling method. Now the number is given over here 1 0 1 1 0 1. Binary, it's a binary number, the base will be 2. So 1 1 2 3 4 5 6. 1 2 3 4 5 6. So we will start with, we have taken base, you will start from the rightmost position. The first power would be 2 to the power 0. So we have it in 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4 and 2 to the power 5. Then you will solve that. You have to multiply 2 to the power. Now 2 to the power 0 it will be 0. 2 to the power 1 into 2 to the 4. Here you can see 2 to the 4, 1, 4. 2 to the power 2 to the 4, 4 to the 8, 8 1 the 8. 2 to the power 4, it will be 0. Whenever you will multiply any number with 0, the answer will be 0 only. Then 2 to the power 5, that is 32. How? 2 to the power 5 is equals to 32. Then its sum will be, when we plus all the digits, the sum will be 45. What will be the sum? It will be 45. Then now we are converting binary into decimals. So in decimal base will be 10. So answer will be 45 base 10. Right? This will be our answer. This is how we convert from decimal binary to decimal. You have to always keep on mind that we have to start from the rightmost component. Now you have to multiply each digit in the binary numbers starting from the right, like I have told you in this form. You will solve this. The answer will be your 45 and its base is 10 because it's a decimal number system. So 45 to the power 10 will be the answer. Now let us understand the doubling method. This is the doubling method. Let's do the doubling method. How you will do it? Write a binary number, start from the lowest. You have to write the binary number and you have to start from the leftmost digit. In that method, we have start from the rightmost digit. Now you have to start from leftmost. Double the previous number and add the current digit. You have to double the previous number and you have to do what you have to do. You have to add the current digit. Since we are starting from the leftmost digit and there is no previous digit to the leftmost digit, we will consider double of the previous digit as 0. Like we have done 1, 0, 1, 1, 0, 1. Base 2, the leftmost digit is 1. So the double of the previous number is 0. Therefore, what do we get? 0 into 2 plus 1, which will be 1 only. Now, continue the same process to the next digit as well as second digit from the left is 0. Now, double the previous digit. 1 ones are 1, multiply 1 is equals to 1 and then you will add the current digit that is 0. So, answer will be 2 only. 1 plus 1, 2 and 2 multiplied by 0 is equals to 2 into 1 is equals to 2 plus 0 is equals to 2 only. Now we are continuing same. Step sequence of all digits, the sum of which is achieved in the last step is the actual decimal value. Therefore, the result of converting binary to decimal using the double method is this method. What we have done, now what you will do, you will multiply this digit with 1 and you will add, multiply by 2 and you will add 1. So 2 ones are 2 plus 1 is equals to 3. So you have to double the leftmost digit. Like this you can see over here. I will tell you step by step. Like we have taken first digit. You have to double the leftmost digit, that will be 1 plus 1, 2, then you will multiply by 0 and you will plus it, your answer will be 1. Next is you have taken 0, right? Now you have to multiply 1 into 2, which will be your 2 plus 0, answer will be 2. Then we have taken 1. You will multiply the leftmost digit, that is 1 plus 1, 2 and 2 into 2. 1 plus 1, 2 and 2 into 2 will be your 4 and you have to plus 1. Your answer will be 5. Now, what you have to do, now you have to take 5, then you have to double this digit, your answer, you have to multiply by 2 and plus y. So, 5 2s are 10 plus 1, your answer will be 11. Next is answer is 11. Now, what you will do, you will multiply 11 with the 2 and plus 0. 11 2s are 22 plus 0 is equals to 22. So, your answer will be 20. Then you have to take 22 into 2, 44 and then plus 1 is equals to 47. So, this is your last digit will be used as a decimal value. Now, we have to convert binary to octal. Now, we have converted binary to decimal, decimal to binary. Now, we will convert binary to octal. The first step is to group the binary digit in the set of 3. Multiply each group adding 0 to divided by 3. First, you have to make the group of 3. Then, you have to multiply each group by adding zeros to divide by 3. Write an octal, the symbol of each group, and this will give you an octal number that comes from a binary number. So, reversing the last two steps will give binary number from an octal. In this, you have to use the base 8. This is the binary number you can see over here. Now, you have to make group of 3. This 100, 111, 010. Here you will put double 0 in front of 1 because we have to make it 3 digits. Now you have to divide it with the what? 3. So, here you will write 1, 2, 001 divided by 3. Answer will be 1. Then here 2 5s are 10, 5, 7 and 4. Then 1274 and base is 8. Now convert binary to hexadecimal. Here you have to make, like here what we have done. We have made a base. One thing I am telling you, for this, you have to learn this formula that I have told you in the starting, when we have convert binary into decimal. I have told you that for 1 we will write 0, 0, 1. Like this you have to learn, then only you can solve this sum. Now binary to hexadecimal. First hexa, in this you have to make the group of binary in set 4. In octadecimal we have made group of 3. Here you have to make the group of 4. And then each quartet gets replaced by hexadecimal, and this will give you a hexadecimal number that comes from binary number. This you have to learn. Then only it will become easy for you to solve this sum. Now let's make the group of 4. Like we have made this, this, this. And in front of this you will write 1, 2, 3, 0. First you see 0, 0, 0, 1. Where it is? It is in this 1. So your answer will be 1. It is written over here. Then we have 0, 1, 0, 1, 0. So see here 0, 1, 0. It is 5. So they have written over here 5. Then we have 0, 1, 1, 0. Where it is? It is 6. So we have written 6. Then we have 1, 0, 0, 1. So where we have 1 here? 9. So answer will be 9. So our answer is 1, 5, 6, 9, and your base will be 16 because it is hexadecimal. Right, this was all in this chapter of number system. Hope you understood all the conversion. You may practice some other questions also with yourself. Now we will meet in the next class. That's all for today. Thank you.